So I hope everybody can hear me, ladies and gentlemen. We are back with the Dialog Forum on chemical recycling with BASF. Now, a first round of discussion. For 20 minutes, we'd like to delve into the discussion. We only have 20 minutes. We received a lot of questions. We will not be able to answer all of them and probably discuss them bilaterally. Now, Yubi Kaba from Brazil has a question to Lars.
Of ChemCycle oil that can be introduced into the steam cracker without harming performance of the cracker. Lars, could you elaborate on that?
Let me answer. Can you hear me? Let me answer that with in two parts. One is, in theory, you can replace all of it, as if the pyrolysis oil has the same quality as naphtha. Currently, I would say the term average is a little bit difficult because it's still in a scale-up. If you look at a world-scale steam cracker today, it consumes about 3 million tons of raw material. And there's simply not enough pyrolysis oil right now. So I think, in theory, we can replace all of it. Until we get there, we still have to scale up the production and use of pyrolysis oil significantly.
Vielen Dank. Thank you. Eine zweite Frage von
Thank you. A second question by Wolfram Littig, I think, goes to Lars Kissau. In how far are foreign atoms negative in the pyrolysis oil? And do they adversely affect the further processing in the flow of materials? Brief answer, of course, they are not helpful. Chlorine, for example, can cause corrosion. So we have to remove it by purification. We heard this before. Pyrolysis oil normally is purified before we feed it into the steam cracker. Yes, okay, thank you. Now a question by Beat Rode from Miele. And Ms. Vogel, we would probably like to refer this to you. Let me read the question.
Be a key tool to solve the trade-off between substance restrictions and chemical quotas. What are the criteria for materials, components, products for efficient chemical recycling? What would be the exclusion criteria? Soll ich es nochmal wiederholen? Waren ja, glaube ich, sogar 3 Fragen, wenn ich richtig erzählt habe. Also, could chemical recycling be a key tool to solve the trade? Können Sie uns hören? Oh, Sie beantworten schon.
The thing is, I'm not 100% sure whether I understand the question correctly, but let me try. Despite everything, materials should be made in a recyclable way, i.e., just because something can be recycled via chemical recycling at the moment, you should not refrain from designing packaging material in a way that it can be recyclable, if possible. Thank you for the brief answer. Maybe we can send you the question and the answer so that we can enter into a bilateral discussion. This brings me to the next question, which comes from Lorenzo Ceccarini from Italy. And I'd like to refer this question to Chetel Byrne and Carlos Monreal. I think Chetel Byrne is still with us. Carlos had another appointment. So, Chetel, the question is...
The residues from pyrolysis. What is done with residues? So it's about what is happening to the 50 residues from pyrolysis. Chetel, can you elaborate on that a bit?
Yes, I can. I mean, we are very conscious, of course, to not have any emissions. In Denmark, we have environmental permits. Of course, there's not much emissions from a small plant like the one we have in Denmark. We have a system. We have talked a lot about pyrolysis oil. I just repeat that we are not producing pyrolysis oil. We're trying to produce naphtha. And in that process, we clean the gas for impurities. We also have a cleaning system for the flue gas. So we have tried to limit any type of emissions as well as we can. The same goes for everything that goes to water. And then the rest will go in an ash fraction. We hope this ash fraction will be of a quality that it could go to chemical industry and or potentially also for producing cement or other things. But in the first phase in Denmark, it will go for incineration and become electricity and long distance heating. So we do have very few emissions from the plant in Denmark.
Die nächste Frage.
Next question comes from Michael Minch from Siflex. And maybe we should direct it
To the 70 yield. Is this referencing the plastic mixed waste as is from the yellow bag, or does it refer to the yield from the pre-treated plastic, e.g. after PVC, paper, etc. is removed? Are these residuals also used to power the process, or is it only the C1 to C5 gas? Did you get the question, or should I repeat it?
No, I got
Okay.
it. What we have done in our study is that we took a sorting fraction, or a fraction from the sorting plant, which is in large amounts available, at least in Germany. Yeah, this is a MK352, which is similar to the MK350, which is available in Germany. And those fractions are high calorific, so they have official specification, and all those substances like paper or metals and so on, they have to be sorted out. I mean, this is disturbing a chemical reactor like in pyrolysis, and therefore we have modeled an extra sorting step to that, and we have asked our technology partner, which is a sorting plant operator, for that, and we included it there. So that means the input of a pyrolysis plant in our model is a quite pure plastic, mixed plastic fraction, free of paper and metal and other stuff. And this 70% material yield in the pyrolysis is referring to that very clean mixed plastic waste fraction. And what we know from this 70% also from our partners, supply chain partners, is also that we are at the beginning of this journey. Because now we are putting a lot of efforts in developing pyrolysis further. And so we are very confident that even that we can, or we at least as chemical industry downstream, that we can also expect much higher yields in the near future.
Okay, vielen Dank. Question from you coming in from Jason Pierce, Eastman, USA. He says basically, it is clear that the conclusion of the study are specific to Germany. From a product perspective, study 2, do you believe that chemical recycling based on pyrolysis can be a carbon footprint advantage in other countries where incineration is less prevalent?
That's a good question. I think
for sure it's a good question. That's a good dialogue.
And thanks for that. I mean the benefit is really on Germany first. So you have to look always into every country what is a specific end of life option. And when there is incineration there, then I think there is a big benefit in terms of CO2. But when you have the situation that, for example, other end of life options, like for example landfilling would be the major one, or you take a fraction from landfilling, then the situation is different. So it's always a case-by-case decision depending on the end-of-life option what you're competing with.
Christian, sorry, but I guess you are again on the hook because Jason sends in another interesting question.
Okay.
I appreciate BASF's transparency in making the full detailed LCA report available. The discussion today has focused on greenhouse gas emissions. The full study also reports on some trade-offs on other impact categories, such as toxicity, for instance, and others. Are these significant?
I mean, sure. When you make an LCA, you have 15 environmental indicators. Yeah, to make a study simple is not so easy. Yeah, to to transport the message. So we focus today on a CO2, but it's correct. In the full report, we have 14 other environmental indicators, and we have used even another environmental indicator set to get the full picture on that. Yeah. There are sure some also, like in every LCA, you have some pros and you have some cons of a technology when you compare the certain technologies with each other. The clear pros is on CO2. And also on resource consumption, yeah, and there are some downsides also or minus, let's say in the acidification potential and also in the summer smoke indicator. Yeah, for a TOX indicator, which would be a quite important one, or at least something which is very interested, at least in the public. Yeah, LCA is limiting, I think, in terms of concrete conclusion. Yeah, first the indicator itself. Yeah, and second, it is also what in our LCA study, depending on the case, depending on a specific situation, you end up, and even a different method set what we have used, you end up with different results for the toxicity potential. So therefore, I would be very cautious to draw any conclusions out of the toxicity from our LCA.
Es kommt jetzt eine ganze Reihe von Fragen hin. Hier kommt eine von
A question by Marco Jungmeier from Germany. Epoxy resins. Let me read the question. Is it possible, when it comes to epoxy resins or other duroplastics, to recycle these? I think there will be high demand coming from blades of windmills that consist of epoxy resins, metal and wooden materials. Well, maybe we...
Whether you got the question. The question is whether epoxy hards or duroplastics can be chemical recycled, because there might be a market when it comes to wind energy appliances and other things. So epoxy hards and duroplast, whether they could be chemical recycled. Maybe that could go to Kjetil.
Yes. No, I think epoxy resin is difficult, to be honest. There are some substances that is difficult for us when there is not a lot of plastic in it. When there is a lot of other substances in it, it's difficult also for chemical recycling. The same also goes for PVC, obviously. The same goes for bottle with oxygen. There is limits to these things. So we have not looked specifically into windmills, even if we are in Denmark. But my understanding is that there's a number of other substances in that material that are not plastic. Same goes for boats. So I don't see the near-term potential for that, unfortunately.
Okay, thank you. So for this round, this is about the marketing claim of the end product. So I guess Eric Bautz, that could be a question for you. The question basically is what kind of marketing claim you could use for end products. I mean, because the questioner, Mr. or Mrs. Bethmann from Germany, says, okay, we can't really talk about recycled here. What kind of marketing claim can be used for end products? Eric Bautz, could you maybe elaborate on that?
Yeah, of course, the responsibility of the marketing claims sits with our customers. We work together with them, we collaborate with them. I think there is two fundamental set of claims to be made here. First of all, chemical recycling products allow you to take a closed loop end-to-end approach to your packaging. Food packaging is being reused as food packaging. I think that's a very strong and important claim to be made. I also think that with chemical recycling products, our recycling quota, overall recycling quota, are easier to achieve. Or put it in another way, to be more bluntly, without chemical recycling, we would never be allowed or never be able to achieve the recycling quota. I think that's another strong marketing claim to be made. How you fine-tune it, how you make it specific for the products that are being used here, that depends on our customers. That's hard to generalize here.
Many thanks. Dankeschön. Eine Frage auf Deutsch.
A question asked in German, but maybe this could also be a question to Erik. Let me read out the question. You advertise that the output products have identical characteristics with products from fossil materials. What makes you say so? Mr. Henn mentioned in the critical review that this needs further proof. Maybe this is the question by Mr. Mustafa. Let me repeat. You advertise that output products have identical characteristics as products from fossil resources, but Mr. Henn in the critical review told us that there is no proof for this yet. Basically, you have to...
Question for whom?
Question, and maybe, was it Cecil or Erik? Would you also like to answer?
Yeah.
Not
Could
really.
I answer that?
Okay, so we have 3 answers to 1 question. That's great. so yeah, Cecil, go on.
No, I disagree with the conclusion because, to be honest, we have just started our commercial plant in Denmark, but we had a demo plant up and running some years ago, and we produced diesel. You can look up Robert Swan. He used that diesel to go to the South Pole. He was there in January this year, and it was within the ASTM American standard for diesel. Didn't reach entirely EN 590 European standard, but it is of the same quality. It comes from the same source, oil and wet gas, and it can be produced to the same quality. That is our goal. It has been done before, and that is what we are trying to do also in Skive, even though we have just started there and we're not there yet. That's the goal of the production in Skive.
Thank you so much. Lars, möchtest du noch ergänzen dazu oder sagst du so?
Lars, would you like to add to this?
Whether the output that we mentioned is the same as the virgin output. If we put the pyrolysis oil, as we said, after purification into a steam cracker, the output is ethylene, propylene, the usual basic chemicals that I mentioned in my introduction. And those are high purity. They are free from all impurities that were introduced with any of the raw materials. So they're essentially indistinguishable, and you can't really mark an atom, but they're indistinguishable on that level. So all for the downstream products have identical chemical properties. They're chemically identical. So it's more of a virtual differentiation. That's why we say the outcome of the whole process going through the whole value chain is chemically and then also from the final properties identical to the virgin product. That would be coming from crude oil.
Thank you. Dankeschön, Lars. Meine Damen und Herren, ich würde jetzt...
Thank you very much, Lars. So with this, I'd like to close the first Q&A session.